A very warm good evening to all. IEEE's Kerala chapter. I welcome you all to the session, Basics of Arduino, being organized as a part of the workshop series held in association with STEMED. I congratulate all the teams who have made it through to the third phase of the program. We are extremely delighted to have you all on board. In the next phase, we'll be conducting a series of workshops in order to guide the students and equip them with the necessary skills for the successful completion of the project. Today's session will be handled by Engineer Anish MS, Global Relations Coordinator, IEEE's Kerala chapter. Sir, Global Relations Coordinator, IEEE's Kerala chapter.
Yeah, thank you, Avanna, for the introduction. First of all, I would like to congratulate all the teams for getting selected to the third phase of this program. It will be a wonderful experience for you always. Hopefully, the content which I'll be delivering today will be a little bit complicated. First of all, I would like to make that a little bit complicated, but I'll try to make it very simple. Hope you all know your native language, Malayalam. I'll try to converse with you in Malayalam. In between, you will be having some doubts. You can directly ask me. You can directly put it in the chat or raise your hands or something like that. Anything is convenient for you. And I'll try to I'll try to conclude this within 1 year, 1 hour, and hopefully we can do it together. And I would like to make this an interactive section. So if you have any doubts, you can straight away come and you can stop me in between and you can ask, what is that I didn't get? Can you please explain it once again like that? Okay. Yeah, I do. I can continue in English, but it will be difficult for you guys because the technical content which is being delivered is much more complicated than what you think. Normally, these sessions are delivered for engineering students in different engineering colleges. We have a wide variety of students here who are ranging from 8 to 10, I guess. Difficult for students who are studying in eighth grade to follow this. So I do not understand Malayalam. Okay, it's okay. In between, I'll switch to Malayalam and come back to English. That's fine. Is there how many people who doesn't understand English? Sorry, Malayalam. Is it a great number? Yeah, there are a few. Okay, cool. Yeah, good. Then I will continue in English. Okay, first of all, I would like to present my screen. Just confirm whether you can see my screen.
Yes, sir.
Yes. Okay. Come on. Is the presentation in full screen?
Yes, sir.
Yeah, cool. So, okay. So the basics of Arduino. So first of all, I would like to know, is there anyone who knows something regarding Arduino? Some basics or something. What is an Arduino? Anyone?
Used for hardware projects.
Yeah, it's for hardware projects. Yes. So these were the contents which I'll be delivering in this session. So this session is basically not we are not going into the depth of Arduino, what is hardcore Arduino, hardcore programming, nothing like that. Just we'll go through the brim of the board and its softwares and all. Just for the basics. So you will be having much more sessions which will be delivering the advanced contents of the Arduino, and this will be the base for those sessions. Okay, so we'll start with microcontrollers and Arduino, then Arduino board and the IDE software, interfacing of Arduino, programming of Arduino, and few of its applications. So this is the Arduino board. You can see the blue one here. This is the Arduino board, and it's an open source board. So many people has many more replicas of the same board. So how the Arduino project was started? Do you know the history behind the name Arduino? Anyone who were interested in Arduino might have known. Yeah. So Arduino is a name which came from Italy, and it is a name of a bar in Italy. Okay, so these people who used to met in a bar, they came up with the idea of creating an open source hardware board which will make programming accessible for students. Okay, so they focused on students like you who are not that familiar with programming, and they made this board in order to make programming accessible for students. So the hardest part of programming is that you will do a lot of programming and you will not get a proper output. The output which you are getting is not physical, not visible like that. So Arduino board is such a board in which you can do the programming and you will get a physical output. Okay, you can see your output, how your code is working. You can see it live. You can connect different modules, you can connect different sensors to the board, and you can get the output in your hands. So that is the advantage, and that is what makes the Arduino board very popular. So it was created in 2005, and it's an open source hardware. Open source means every hardware is visible, its circuit diagram is available in the net. You can directly go ahead, buy a board, buy the components, and you can create one. You can create your variety of Arduino board. All those things are possible because it's an open source hardware. And it is mainly done for making the coding accessible and transferable. And the coding which we use is C++, Java, etc. And this is the board. The board itself you can see. And am I visible to you? Can you see me?
Yes, sir.
Yeah, okay. So I have a board with me. I cannot see my video, whether it's visible or not. I have a board with me. This is the same thing which you are having in the screen. So the Arduino board has few parts. I'll try to explain one by one. So you can see a chip right here. This is the Atmel chip, Atmega 328. You can see the naming here. I don't know whether it's visible or not. Atmega 328 is the name of the chips. So you all are using computers, right? So your computer will be having Intel microprocessor, AMD or something like that. So this is the microprocessor of this Arduino board. So what is a microprocessor and a microcontroller? Do you know the difference between microprocessor and a microcontroller?
Yes, sir. Microcontroller is a combination of microprocessor and some other input-output.
Yes. So microprocessor and microcontroller. So controller is just controlling the entire devices, and if you combine some other external and internal devices. For example, input output devices, you will get a microprocessor like that. It's not that complicated. You can just directly go to the internet and search for the differences. You'll be having some tables differentiating between the differences of microcontroller and microprocessor. So this is the microprocessor of our Arduino board, which is at Mega 328, and the entire board, okay, is a development board. This Arduino board is known as a development board. So it has all the components connected to it. So it's called a development board. And these are the parts. So you need a power for powering up this microcontroller and all these things. So in order to power up, you have the power pin here. So you can see the view right here. You'll be connecting the power cable to this point. It's a DC jack. You'll be taking 12 volts power, 12 volts or 5 volts. Anything is feasible for it. From 5 volt to 12 volt, anything is feasible. And this port right here, you'll be connecting the wire, the connection wire, which is to be connected to the computer. It's a kind of a USB cable which you usually use, and you can do this connection like this and just connect to the USB port of your computer. Part is done. This is the powering up, and this is the connection to the computer. So if you are directly connecting to the computer, you need not to power it up, because the USB will be providing the required power from your computer to the Arduino board. Reset button here. This reset button, if you have done a program into the Arduino board, and currently a program is running in the Arduino board, and if you press on the reset button, it will directly go back to its default program. Its default program is the blink program, which is being programmed to the 13th pin and the default LED. Okay, and we have a digital. Sorry.
The default I didn't get.
You didn't understand the default program. Okay, I'll get to the default program in a while. We have the during the programming session, you'll be having the default program. So I'll simply explain what is the default program in Arduino. Once you buy an Arduino and you just can't power it up, the 13th pin will be connected to this LED light. You can see this pin 13 LED. You can see this L here. Is it visible for you?
Yes, sir.
Yeah. So this 13th pin will be a yellow LED if it is a default Arduino board. Then it will be blinking in a time span of 1 second. Okay, so it will be on for 1 second, then off for 1 second, on for 1 second, off for 1 second, like that. So that is the default program loaded in an Arduino board once you buy a new Arduino board. So if you have done a lot of programming and if you press the reset button, then it will delete the entire program in the Arduino board and it will come back to this default program. I hope that done the purpose, you understand the default program. And then we have the digital input output pins. Okay, so I had already mentioned about the sensors, input output devices, like that. So if this board is needing something from the outside world, okay, you can use these digital input output pins. So if you can connect your LEDs, your motors, etc. in these pins from 0 to 13. And in between you have some PWM pins. I would like, okay, I'll not be explaining about the PWM pins because it's pure electrical engineering. And I'll try to explain it during the analog read and analog write explanations, because I'll simply say, in digital, you have 0, 1, 0, 1. Okay, and in analog, you have 0, 1, 2, 3, 4, like that, up to 255. Okay, so it will be a continuous value. And in digital, you have 0 and 1, ups and downs. Okay, so that is the difference between digital and analog. And we have all these pins are compatible for digitals, but these 11, 10, 9, 5, 6, 5, 3 are compatible for analogs or PWM pins, PWM inputs. And we have analog input pins. You usually connect the sensors which will take the values of resistance, light, etc. If you are using, for example, a light sensor, the amount of light will be converted into an analog value and it will be taken as an input through these analog pins. So these are the digital pins, these are the analog input pins, and then we have the power section. We have the power section here. So we have a V in. You can see a V in here. Is it visible? I don't know whether it's visible for you. If you're seeing from the lab, then you'll be able to see this thing. We have a V in here. It is an input voltage pin, and this input voltage pin will be serving as the power. If you don't have the power in, and if you don't have the computer, the USB connection to the computer, you can directly put a battery here, connect it to the V in, and connect the next to the ground. Then it will be powering the Arduino. Okay, simple. And we have 3 grounds, 2 grounds here and 1 ground here, 3 grounds total in Arduino, and the entire connection should be grounded. And we have a 5 volt. Sorry?
All have same purpose, the ground.
Yes. All the ground has the same purpose. Similarly, for example, if you're connecting an LED, okay, if you're connecting an LED, okay, this is an LED, for example, and you'll connect to the positive to the 5 volt, and you'll connect to the negative to the ground. Then the LED will be powering on. Okay, so this 5 volt will be providing a 5 volt output, and this V in will be taking in a 5 volt or 12 volt. But this 5 volt will be a regulated voltage which will be providing a 5 volt. It's like building a game. If you're playing around with Arduino, it will be like building a game or something like that. So it will be very cool to play around with Arduino. So this is the 5 volt output, and then some sensors which require 3.3 volt output. It will not take 5 volt output, it will take 3.3 volt output, but much more current required. So such pins will be using this 3.3 volt, and this is also a reset button. This reset button is same as this reset button. If you don't have if this button is not working, then you can just put a 5 volt input to this reset. For example, if you short this 5 volt and this reset, connect a wire between this 5 volt and this reset, then
but all this time electricity is being supplied, right?
Sorry?
All this time electricity is being supplied.
All this time electricity is being supplied. Yes. Current is being supplied to this board through the power in board or through the USB port. That's okay. It has the internal blocking systems and all, so you don't worry about the short circuits and all. It will not happen. And if you connect this 5 volt and this reset directly, then the entire program will be reset, similar to the purpose of this reset button. And this is an input output reference switch, which will not be using much. Okay, and what else?
The PWM pin.
Yeah, these are the PWM pins. PWM means okay. I will explain it in the coming sessions, because there is a dedicated session for the digital and the PWM pins. It's kind of PWM means pulse width modulation. Okay, pulse width modulation. You will be studying it in the higher classes. I don't know. You are from which standard?
I am 10th.
10th. Okay. Have you studied anything regarding the electricity in your physics or something?
Yes, sir, but not this.
Yeah, that's why I told you it will be a little bit complicated for you guys, but you can study. It's not that complicated, but you can study. If you try, you can study. So how can I explain this? Okay. So PWM is pulse width modulation. That means these are the pulses. Okay, these are the pulses, and this is a high and this is a low. Okay, this is a 1 and this is a 0. So if you send such a signal to the LED bulb, then the LED bulb will be receiving a 5 volt and a 0 volt, a 5 volt and a 0 volt, like that. So what will the LED be doing? If you take an LED, if you connect a battery to it, and you also inserted a switch, and you suddenly switch on the bulb, and then it will be having a high. Okay, then you switch off, then it will be having a low. Then you switch on, then it will be having a high, like that. Okay, this is the digital input. And if you have an analog input, that means, for example, You all know about the radio, right? Radio system, the radio tape recorder or something like that.
Yes,
It
sir.
will be having two this thing like that knobs. Okay, you can rotate these knobs for
Yes,
increasing the volume, right? For
yes, sir.
increasing the volume and decreasing the volume. That is a PWM pin, PWM input. Okay, so there you are gradually
Adjusting.
increasing, gradually decreasing, gradually increasing, gradually decreasing, not an abrupt rise and abrupt down, right? So this is the PWM, and the other one is digital. Hope you understand a little bit.
PWM is the analog, the gradual increase and
Yes,
decrease.
PWM is the analog version of this thing. So here we have an abrupt change from 0 to 1. There we will be having a gradual change from 0 to 1, and then gradual change from 1 to 0. And you will be accessible with all the values in between. Here we will be accessible with 0 and 1. Here you will be accessible with 0, 1, 2 like that. The values in between 0, 0.1, 0.2, 0.3, 0.5 like that till 1. You will be accessible with all these values. So for example, if you are putting a digital signal to an LED, okay, then it will be off and on in the complete brightness, off and on in the complete brightness. But if you're putting an analog signal to an LED, okay, then what will be happening is that it will be off, then gradually the brightness will increase to the maximum. And then you can gradually decrease the brightness from maximum to 0. Okay, it is the difference between blinking and fading. Blinking means high, high, low, like that. But fading means
Slowly.
from low, it will be gradually going to high and then gradually coming back to low. So that is the difference between PWM and digital inputs. Okay,
Yes, sir.
and that's all about Arduino board. Now, how you will be connecting, which I had already mentioned. This is some other board created by
Red and blue
SparkFun.
both are same.
Yeah, both are same. I had already mentioned it's an open source board. So open source board means you can create your own board. You go to the shop, buy a breadboard like this. You can see a breadboard here. This is a small breadboard. You buy a breadboard like this. You can buy all the components, this chip, all the power jackets, all these things required, capacitors, resistors, inductors, everything you buy, and you can create your own Arduino board. Okay, some companies are making such Arduino boards other than the Arduino foundation. So this is some other kind of board similar to Arduino board. Everything will be having the same purpose, but little bit changes will be there. So you can connect this to the USB port, simple. So that is the interface of the Arduino with the PC. So this is a simple way to connect to the Arduino.
So there is
And
a doubt.
yeah, yes. What is the doubt?
Is it recorded?
I don't know. Organizers, is it recorded?
Yes, sir. Yes, sir.
Yeah, okay, it is recorded. So if you want, you can take the files later for your references. So, okay, so I explained the connection. You'll be connecting this point to this here and this point to your USB port of your computer. Then the connection between this Arduino board and your computer is ready, and now you can start the programming. Now, in order to program the Arduino board in your computer, okay, so you can go to this website. This is the official website of Arduino. Yeah, so this is the official website of Arduino. You can download the softwares from here. Arduino IDE is the software. You can download for Mac, you can download for Windows, and anything is possible. You can download the software and you can just install the software. That's it. It's very simple. Once you install, see, these are the versions available. You can for Windows directly download for Windows, and also for Linux, and also for Macs, and anything is possible. Okay, so this is a link. I'll provide the link in the chat box. if you have the PC with you, you can directly go. So I had posted the link on the chat box. You can directly go there. Yeah, and download and install. That's the simple procedure of the software. And once you download it, you will be having such a window. So this is the IDE of Arduino. Okay, Arduino IDE, it's very famous, and it's the integrated development environment. It's called the integrated development environment. So you have the entire development of the program being done in this software. Okay, and I would not like to explain the coding very much because you have a separated coding session in the upcoming sessions. So I'll simply explain what you see in the screen. Okay, so the entire coding can be divided into two parts. Okay, the entire code is written here, and the code can be divided into two parts. One is setup and one is loop. Okay, so what do you understand by setup and what do you understand by loop? Anyone?
Setup is a starting, loop is a repeating.
Yes, setup is just setting up. We are setting some constraints. Okay, we are saying that okay, this pin is for output, this pin is for input. Okay, this pin does nothing. Okay, like that we can define all those things. Okay, that is a setup. Before doing something, we will do the setup, and then we need something to repeat continuously. Okay, this will run once because before starting the program, it will run the setup and then set all the input output pins ready and then run the loop. Inside the loop, you can do the continuous programming. Okay, for example, you are writing a program to blink the LED for 10 seconds. So 10 seconds, it will be continuously up, down, like that. Okay. And you can write that loop here, but you need to say to the Arduino board that, okay, I am using this particular pin as the input pin for the output pin for the Arduino, and I am using this particular pin as the input pin for the switch, like that. All these things are done inside the setup, and the remaining things are done inside the loop, where you say, okay, you have to run for continuously for 10 seconds, continuously for 20 seconds with a gap of 1 second in between the blinking, like that. All these things are done inside the loop. I'll simply explain one simple code, which I had already mentioned the blink code in the upcoming slides. So this is the Arduino IDE software, which you get once you download the software from the website. Okay, and I'll also explain the other things. You have the file here, the edit here. Inside you have tools here. Inside the tools, you have to select the Arduino board. Which board you are using. All those things will be explained while explaining the software. I'll simply say what all things are visible here. This is a compiler. Yeah, you can use any language. Mainly we will use C++. You can use Java. You can use Python. Anything is possible. But mainly we will use C++. Okay, so this is the compiler. You can simply write the code and click on the tick mark, and it will say if there is any error. The errors will be displayed here. And then this is the upload button. Okay, and then we have this serial monitor. Serial monitor. If you are using a sensor, for example, if you are using a light sensor, and you are directing some light towards the sensor, then the value, the analog value which is being created by the sensor will be somewhat low. For example, it will be 0, 1, 2, 3, 4, 5, 10, like that. And if you're not providing any light, then the value will be high, some thousands, 100,000, like that. Okay, so these values, yeah, based on the brightness. So these values, you need to analyze these values to do the programming. So in order to analyze this value, you need a monitor where you need a monitor where these values will be displayed. Okay, that monitor is the serial monitor. Once you click on the serial monitor, a separate monitor will be displayed, and inside that monitor, these values will be coming like that. Okay, so once you turned on your light, then the value will be increasing, decreasing, like that. All this thing can be visible in the serial monitor.
How it is functioning, we can see.
Yes, how it is functioning can be seen in this serial monitor.
The tick is
And
for what? I didn't get.
what?
The
This
first
tick
one.
is the compiler. Compiler is
Mistakes.
sorry.
Checking the mistakes.
Yeah. What all things are there in this program is these indentations are correct. So if you have put all the brackets correctly, if you have put the semicolons correctly, and the things will be checked by the compiler and it will be showing the errors here. Okay, so you can see the red errors like this. If you have a lot of errors, it will be displayed here, and you can read it down and you can understand, okay, there is a error in the line 13 or line 21, and you can directly go to the line 21. If you click on the that particular line, it will be showing that line and you can detect the error there. Okay, it's part of the programming and will be taught later. You need to know two concepts. Okay, the concept of input and output. Okay, you know what is an input and output, right? Input is a signal. This is being explained on the basis of the microcontroller and electrical board. Okay, not on the basis of our normal inputs and output. It's somewhat similar. Okay, input is a signal or information going into the board. For example, sensor values. Okay, okay, you are doing a project in which you need to sense how many people are inside a room. For that, you will be using a PIR sensor, proximity sensor. Okay, so this PIR sensor is an input device. You'll be connecting this PIR sensor to some analog input pins from A0 to A6, and this input value will be acting as an input signal. Okay, it will be sensing the heat, and it will be sensing the number of people inside the room, and it will be sending a particular value based on the number of people inside the room to the Arduino board. So this will be acting as an input signal, and we need an output signal. For example, if you are doing a project stating that if the number of people inside the room is greater than 20, for example, if we have the corona pandemic right now, right? So the number of people inside a particular room should be limited. So if you're doing a project like that, and if the number of people inside the room should be less than or equal to 20, then you have to do a constraint. If the amount of people, number of people inside the room is greater than 20, then you have to put an alarm. Okay, an alarm should be fired, and for this alarm will be acting as the output. Okay, so the sensor will be acting as the input and the alarm will be acting as an output. Okay, so that is the basic concept of the input and output in the microcontroller. And can anyone say some other examples of input and output? Which you know from your real life experience or something like that?
So before that, I have a doubt on the programming part again. That values.
Yeah, programming parts, doubts on the programming parts will be cleared in the programming session. Is it something related which I had already mentioned? Yes.
Yes, sir. That values you told something.
Which values? The analog values of the sensors.
The light value, something, brightness.
Yeah. That I will explain while doing this point. Okay. Yeah. Do you know any examples of the output and inputs? Yeah.
Normal condition.
Yes, the button switches, which are the input devices. We all are using switches, right? These are the input devices. Then the light sensors, flux sensors, humidity sensors, microphones, temperature sensors. All these things are input devices, and we have the output devices like LEDs, DC motors, servo motors, piezoelectric buzzers, relay, RGB LED, etc. Are you familiar with all those things? LEDs, DC motors, servo motors, you might not be familiar. Piezoelectric, I don't know whether you are familiar. Relay, you might not be familiar. RGB, you might be familiar. Sorry?
RGB LED is normal LED.
RGB LEDs are not normal LEDs. RGB LEDs are
green and blue.
red, green, blue LEDs. That means it will be having normal LEDs will be like this, right? Having 2 pins. RGB LED will be having 4 pins. Okay, so these three, one will be the common and three will be R, G, and B.
So in one
So
LED
RGB
we'll
LEDs
have
are the
three
normal.
colors.
Yeah, in one LED you'll not be having three colors. You will be having multiple colors
The
based on the
values will be
voltage given
changed.
to particular point. If you are putting R as, for example, 255 and G as 0 and B as 0,
Red we will get.
then the red will be fired. Okay, then if you change the color, then you can change the numbers. You can
So many colors.
change the different color, change the different colors. Yes, and if you can directly give the code of this particular color, for example, FXXX like that, and then like what 0000 FFFFF like that. All these codes are also possible. It's part of complicated programming. Just leave it. So then what else? Piezoelectric buses. You know, are you
No,
familiar with piezoelectric buses?
Yes,
DC
sir.
motor is for converting.
No, I was asking about piezoelectric buses.
So that I don't know.
Yeah. Who said yes?
Me.
Yeah. Can you explain what is
In
piezoelectric
alarm,
buses?
in alarm clocks we use,
Yeah,
or
exactly,
in
exactly.
watches.
Yes, in alarm clocks, and in your watches, you will be using these piezoelectric buses for the alarming system. So, piezoelectric buzzer is something similar to a speaker, but it will be working on the basis of the pressure you are applying. Okay, the pressure difference between the two plates will be acting as the buzzer. Okay, that is a piezoelectric buzzer. Then DC motors, you will be familiar because all the toys, all these simple toys which you will be using will be having a DC motors. And servo motors is same as a motor, but it will be having this rotations like from 0 to 180 degree. Okay, it will be having something like this, and it will rotate from here to here and then back like that. It's a servo motor. Yeah, relay. I'll explain what is a relay. A relay is simply a switch. For example, this is a switch. You need to control a bulb which is running on 230 volt. Normal your bulbs will be running on 230 volts. Okay, it will be having 230 volt. So will not be able to control this 230 volt directly, because if you directly give 230 volt that to AC into an Arduino board, it will be burned off. We are working on 5 volt DC. Okay, so this 5 volt DC need to control this 230 volt AC. So for that purpose, we'll be using a relay. Okay, in which two pins will be connected to this 230 volt, and we will be having pins to connect to this Arduino board. Okay, so that is the purpose of the relay. Relay will be a switch acting as an interface between the Arduino board and this 230 volt circuits. Okay.
DC motor and AC motor, what is the difference?
Yeah, DC motor and AC motor, the simple difference is DC power will be using in DC motors, and in AC motors, AC power will be using. Simple. The motors which you see in the toys, in your toys, your cars and all, it will be a DC motor. It will be running on a battery of 3 volts or something like that. It has a permanent motor. If I go on to the hardcore explanation of DC motors and AC motors, it will not stop now. DC motor will be a motor which is running on DC power. You can use batteries to power it. Those are motors like this, generators. It is displayed like this, generators or motors, and it will be running on AC power. Okay. The simple example is that your pumping motor, right? You will be having the pump to pump your water to the tank. Okay, so this pump will be an AC motor. You will be connecting it to the 230 volt AC. Okay, and your fan will be an AC motor. To be precise, it will be a single phase induction motor, and it's complicated. Yes, leave it. And the DC motor which you are using will be what?
Small functions.
Yeah, not small functions. For the very big functions, we are using DC motors. For example, DC motor fans are there. I'll simply show you an example. Yeah, this, can you see this thing?
Yes, sir.
Yeah, it's a fan which is running on DC. You can see the whether it's visible or not, I don't know. You can see the specification right here, right? It's input voltage of 5 volt DC. Okay, it will be running on 5 volt DC. And for example, if you look on the charger, okay, charger, you will be having an input of 230 volt AC, and you will be having an output of 9 volt or 5 volt DC output. Okay, so the difference is that the power which you get from the electricity board, or power which you get from this plug point, will be AC, alternating current. Okay, the current will be alternating like this. The power which you get from a battery, it will be a DC, it will be a straight line. Okay, it's like CRO, DSO, etc. to view the current flowing. And if you, for example, I will simply Google it. 1 second.
So what is the
DC and AC. And I'll show the images. So see, this is a DC voltage because it has a constant voltage here. Okay, you can see the plus sign. It has a constant voltage which might be 5 volt. If you have a 5 volt DC voltage, then it will be continuously supplying 5 volt. Okay, but in an AC voltage, it will be alternating between to 5 volt, coming back to minus 5 volt, going back to 0, then 5 volt, like that. It will be an alternating. It will be changing the phases, changing the angle. There are a lot of complications. Yes.
That's
There
why
are
fan
all things-
speed there will be differences in our fan speed. Sometimes it will be fast, sometimes it will be slow. Even if we have fixed the speed.
No, it's yeah, somewhat similar. Yes. For example, I'll explain it. If you have a voltage drop, okay. If you have a voltage drop in your electricity supply, okay. Sometimes we will say that there is a drop in voltage, so we cannot run some machineries like that. Okay. So this voltage drop is something like the peaks will not be there. Okay, it will not go up to. Yeah, it will not go up to this point. It will go in between and come back, and then go back, not to up to that point. Okay, so that is the reason why your fan speed will be reducing. Where were we? We were here, right?
Input and output.
Yes, input and output. So, okay, from where did we get this DC? Okay, from DC and AC motors. Okay, so simply the DC motors are the motors which you use in simple applications like the toys, DC fans, etc. And it has more complicated applications. Like there are DC trains. Okay, trains running on DC motors. There are
So that if you
huge
have
applications.
something like batteries.
Yeah, it will have batteries. It might not have batteries because we have the facility to convert this alternating current to direct
Like
current.
the
Okay,
Arduino
if you have an alternating current like this, and if you send it through something, there is a box here, and this box is little bit complicated. It's pure electrical engineering, and if you send this thing through this box, and you will be getting an output. Okay, these are converters, AC to DC converters. Okay,
The relay is something like that, right?
relay is nothing like that. Relay is just a switch. Relay is not a converter. It's just a switch. But inside a converter, you have a lot of electronics. Some diodes will be there. These diodes will be acting as an AC to DC converter, like that. It's complicated. Leave it. It's not up to your level to explain all those things. So if I start explaining those things, then we'll be deviating from the topics. So just know this thing. There is something called a converter, for example, an AC to DC converter, in which if you supply an AC current, okay, if you supply an AC current to 30 volt AC current, you will get a DC output. So you don't need a battery directly. For example, your charger, phone charger. Inside the phone charger, you have this converter which has a transformer, some circuits, capacitors for filtering, all those things. Okay, so you will be supplying a 230 volt input and you will be getting a 5 volt output. So inside that block in the charger, inside this block you have the converter. Okay, that is an AC to DC converter, and you have the possibility to convert back the DC to AC. For example, your solar power. Okay, solar power is directly coming as DC, and it will be stored in the battery pack. If you have an inverter in your home, it will be storing in a battery pack, and from that battery we are getting 230 volt AC, right? This 230 volt AC is getting because we have a converter in between which will be converting from DC to AC. Okay, a reverse conversion is also possible. So these are power converters. Solar
or DC.
Solar panels are DC. Solar panels will be it's kind of a battery, light sensor, example anything. So it will be converting the sunlight directly to DC, and this DC will be stored in the DC batteries, and from the DC batteries you will be converting it to AC by using the DC to AC converter, and from that it will be feeding to your circuit, your home circuit. That's how you get the power once the power outage is on. Okay, and you have other possibilities also. For example, you take the AC, you convert it to DC, you store it in the battery, and then you convert back to AC, and then you use it for your fans or something like that, light, etc. Okay, this is the diagram of the inverter which you might be using, not the solar inverter, the normal inverter. Normal inverter will be powered from the supply. Okay, normal inverter will be powered from your home supply. It will be converting that AC to DC for charging this battery, and this battery will be storing the DC power. And once the power is gone, it will convert this battery power, DC power, to AC using the DC to AC converter, and then it will be supplying the AC. Okay, so that is the difference between DC and AC. Not part of this presentation, just an extra topic out of curiosity. Okay, then the examples of input, you have button switches, the up down switches which we use, and light sensors, example LDR, light dependent resistors. Then you have what the solar panels will also act as a light dependent resistors. Then you have light dependent transmitters like that, and we have a flex sensor. You know what is a flex sensor? Anyone?
Light sensor is sensing the light brightness and everything.
Yeah, light sensor is sensing the light. What is a flex sensor?
How much
Maybe the
bending?
motion.
Yeah, exactly. How much bending? Exactly. So you have is a flex sensor like this, and if you attach this flex sensor to your for example, this is a flex sensor. Okay, imagine this is a flex sensor. You attach this to your finger, and if you're bending your finger, the sensor will be bending. Okay, depending upon the bending, the values will be changing. The analog values will be changing. Okay, for example, if the sensor is straight, then you will be having a value of 0, for example. And I bend the sensor a little bit like this, then the value changed from 0 to say 10. Okay, I bend a little more like this, then it changed from 10 to 20, and I bend it like this. Okay, then it changed from 20 to 50. Okay, so you can monitor in the serial monitor and you see that the value is 50. Then you understand, okay, the sensor is right now like this. Okay, you observe that the value is 20, then you understand the sensor is like that. Okay, this is the purpose of the flex sensor. If you are doing something, for example, now how we can use the flex sensor? You are attaching 5 flex sensors to your hand, and you model a robot exactly like you, and it also has a hand, and you need to mimic the robot need to mimic your actions. I am doing like this, I am doing like this, then robot should also do like this. I am doing like this, then robot should also do like that. For that purpose, you can use a flex sensor. Okay, because I am doing like this. Okay, then the microcontroller understand that the flex sensor has bent. From here to here, the flex sensor has bent. Okay, this bend is the data is sent from the microcontroller to the robot. Okay, now the robot understand that, okay, the flex sensor has bent, so I should also bend my finger. Okay, this is how the working. So then the robot will also do like that. Then I do like this. Then the robot understand the flex sensor, 4 of the flex sensors has bent, and then this data will be sent to the microcontroller. The microcontroller will send this data to the robot, and the robot understand that, okay, 4 of the flex sensors has bent down. Okay, then I should also do like this, and the robot will be doing like that. You can see the search on the YouTube for robots which are mimicking the actions. For that, you can use the flex sensors. And now we have advanced technologies. Machine learning is there. We have computer. Cameras are there. So instead of using this flex sensor, you will simply use a camera and machine learning, and it will understand. Okay, this is a hand, and it will draw lines like that. And based on the movement, the lines will be moving, and the same process data will be sending. Okay, instead of flex sensor, you can use machine learning. Almost everything can be
values for flex sensor is 0 to 50.
Sorry. No. It's just an arbitrary values. It's not 0 to 50 like that. You will get to know once you start using the sensors, because each sensor will be having different values. Okay, so analog values will range from 0 to normally 255 based on the voltage values. The voltage will be from 0 to 5. And the analog values will be from 0 to 255. And there is a process called mapping. Okay, in the mapping, you'll be mapping the 0 to 0 volt to number 0, or number 0 to 0 volt, and number 255 will be mapped to 5 volt. Okay, in between you can have the values, and these numbers can also be mapped. For example, if you need precise control. Okay, precise control means here you have only access to 255 numbers. You need thousands of numbers. For example, you need this position, this position, this position, all these positions are required, and you will not be able to control this entire thing using this 0 to 255. You might need to use 0.1, 0.1.234 like that. Okay, it will be difficult. So for that purpose, we'll be mapping this 0 to, for example, 0 to 0, and this mapping this 255 to say 10,000. So this 0 volt will be equal to 0, and 5 volt will be equal to 10,000. Then the values will be from 0 to 10,000.
Like
You'll
a
be
scale.
0, 1, 2, 3. Yeah, it's kind of scaling. We'll be calling it the map called mapping in case of programming. Okay, in case of electrical engineering and programming, we'll be calling it as mapping. And humidity sensor will be sensing the amount of moisture content in the atmosphere. Temperature sensor will be sensing the temperature. You will be, for example, I'll show you. This is a clock. Can you see this clock?
Yes.
It has a temperature sensor, and you can see the temperature displayed 22 degrees Celsius.
So we get
Yes, sir.
Yeah, that is the purpose of the temperature sensor, and it has a light sensor. I don't know whether it's visible for you. No. It also has a light sensor inside this thing. So once it is dark, it will automatically turn on the light. So these are the purpose of the sensors. Hope you understand a little bit.
yes, sir.
Okay. How much time we have? We have a few more minutes, right? Okay. Now the concept of analog and digital, which I promised to explain earlier. This is the concept of analog and digital. Microcontrollers are digital devices. Okay, microcontrollers are digital devices, on or off. Okay, then we need the analog values. How are we processing with analog values? Analog signals are anything that can be a full range of values. Okay, so simply this point, for example, I'm drawing a line like this, okay, and I am drawing a line like this, okay. At this point, what is the value of my output? This is an output signal, okay. This is an output signal. What is the value of my output? I'll go like this, and it is 5 volt. This point, it will be 5 volt. This point, it will be 5 volt. This point, it will be 5 volt. and I came to this point, it will be 0 volt, right? This point 0 volt, this point 0 volt, and again at this point again 5 volt. So if I analyze this thing, the output will be at some point. This is time, okay? This point is time. For example, this is 0 second, first second, second second, third second, like that. Okay, this is time and this is voltage. This is the time.
X-axis is time.
Yeah, x-axis is time and this y-axis will be voltage. And if I analyze for all the particular times, for example, this is 0 and this is 5 volt, and this is, for example, 1, 2, 3, 4, 5, 6. Okay, if I observe at first second, the value will be what? 5 volt. If I observe at 1.5 seconds, value will be 5. 1.75 seconds, it will be 5. And at 2, it will be 0. Then 2.5, 0. 2.75, 0. 3, 0. 3.5, 0. Like that. So the values which is coming in the output will be 0 or 5 volt, right? In any time. But now analyze this signal.
Analog.
Yeah. So I have a signal like this. And this is a voltage. It will be 5 volt and this will be 0 volt. For example, I say this is 1, this is 2, this is 3, this is 4, and this is 5. Okay. So now I observe at 0.5 seconds. Okay, 0.5 seconds. This is a 0.5 second. What is the value? 0.5 seconds. For example, this is 2.5, this is 5, then this is 2.5. This might be around like 1.75 or something. So at 0.5 second, the voltage will be 0.75. Now I observe at 0.1, it will be around 1.75 or something, right? This 1.75. At this point, it will be more than 2.5. Let's say it's 2.75. And this point, it will be 5. Then at 3.5, it will be like around 4.75, like that. So we have the values here. We have the value either 0 or 1. Either 0 or 1 is the only possible values in digital, right? But in analog, we have 0.75, 1.75, 2.5, 2.75, 5, 4.5, like that. In between, all values are possible from 0 to 5. Okay, that is different between what analog and digital signals. And I had already explained how this analog values can be used for, instead of blinking, you can use fading, right? So that are the two concepts which you need to know in the basics, okay? There are a lot of concepts, there are millions of concepts, and all these concepts can be learned gradually, but right now you need these two concepts, concept of the input output and concept of the analog and digital. Okay, and some big concepts. Okay, this is part of programming. Okay, this is part of programming, but this is also basic. So that's why I'm explaining this thing.
The microcontroller is the one which has microprocessor input, output, and everything, right?
Yes. And what? Okay, digital write, analog write, digital read, analog read, all these things. Okay, I'll explain what all these things purpose. These are the part of the programs. Okay, if you are writing a program, you are writing digital write a particular pin. For example, digital write 9, output. You write like this, digital write 9, output. Then what it means is that the microcontroller, that this 9th pin, okay, 9th pin is set as an output pin. One second, let me think. Okay, no. For example, I am writing like this, digital write 9, high. Digital write 9, inside this bracket I am writing digital write 9, high. Then I am telling the microcontroller that this 9th pin, in the 9th pin, I am sending a high voltage. Okay, if I send this thing, digital write 9, high to the microcontroller, then the 9th pin, you can see the different pins here. Different pins are here, and in the 9th pin, I am connecting a LED bulb, and I write this code, digital write 9, high. Okay, this means 9th pin, I am sending a 5 volt to the microcontroller. The 9th pin of the microcontroller is being set to high. Okay, now the LED bulb connected to the 9th pin will be glowing. So the 5 volt required for the LED bulb will be received in the 9th pin and it will be glowing. Okay, and that is the purpose of the digital write function. Okay, now we have the analog write function. Can anyone say what will be the difference between the analog write and digital write while writing? For example, I am writing 9, what?
One value you have to write.
Exactly, one value. You can write 0, then the 9th will be 0. If you write 125, okay,
It's
you
between
write
255 and
125.
0.
Yeah, not any number between 0 to 255 you can write. Okay, if you write 3, if you write 7, if you write 200, anything is possible, and based on this value a particular voltage will be sent to this LED bulb. So it will be fading, it will not be blinking, it will be fading. So if you put 3, then a very feasible light will be there. If you put 255, then the brightest point will be there. So that is the difference between analog and digital write. And digital read is mainly for the switches. You can see the switches here, right? So if you
Digital write.
sorry,
Digital write.
did you get analog
That
write? Did you understand?
Intensity of the light.
Oh, regarding the intensity of the write, digital write we don't have intensity. Come to the point.
Analog write is intensity.
Okay, so
Digital I didn't get.
oh, digital write is simply on and off, nothing much, just on and off. Digital write, if you put digital write 9, high, then the LED will be turning on, and if you put digital write 9, low, then the LED will be turning off, just on and off functions. But in analog write, you can 0 brightness, first brightness, second brightness, like that you can increase the brightness. Okay, that is the difference between digital write and analog write. And you understand?
The bulb LED will connect it to 2 pins.
Yeah.
One is a 9 pin and another is the ground, or the ground,
Yeah.
right?
Is it the ground or anything else?
Ground.
Yeah, I had already explained that. Okay, so normally we will connect the positive pin to the digital pins and the negative pin to the ground. You can do the other way also. You can put set some particular pin to the 0 and you can connect it to the negative pin to that. All these things are possible, but in the basic you will say that you will connect the positive to the digital pin and negative to the ground. Okay. Once you get familiar with all those things, once you start doing projects and all those things, you will have lots of possibilities. And now we'll be explaining about the digital read function. Okay, digital read function is mainly for the switches. If you have a switch and you need to take a value from this thing, okay, you are connecting a LED bulb and using this microcontroller to control it, and you press a switch and you need to turn the LED on. Okay, so this microcontroller need to read whether the switch is pressed or not. So once the switch is pressed, a particular signal will be sent to the microcontroller. And if you're connecting this switch to the 8th pin, for example, digital read 8. Okay, if you write digital read 8, then the value in the 8th pin, it will be either high or low. Okay, either high or low will be read by the microcontroller. Okay. So if you are pressing a particular button, then a high will be sending a high will be sent to the microcontroller. If you are not pressing, then the value coming from the 8th pin will be low. So that is the purpose of the digital read. Similar is the purpose of the analog read. Okay. For example, instead of using this particular switch, you are using the slider or the
Regulator type.
The knob, regulator type of knob, which I had already mentioned. Okay, if you're using these knobs, then the value will not be 0 and 5 or low or high. It will be between 0 and 255. Okay, based on that, we can set the brightness. For example, if you are doing a project to increase the brightness of an LED using a knob, then you can use the analog read function. All these things will be explained in the programming session. Okay, then we have the if statements. If statement, I'll explain. There are a lot of condition statements. Okay, one of them is if statement. We have if, while, and lot of condition statement go All these things are condition statements. Okay, and I'll simply explain what is an if statement. Okay, you can put a condition here inside this bracket. If I have a variable right here, I have a variable a is equal to 10. Okay, and this value is coming from a sensor. I have connected a light sensor, and this value is coming from a sensor. Okay, I had done analog read a like that, and a is equal to 10. If a is greater than 10, okay, if a is greater than 10, then I can write a condition. If a is greater than 10, I can do a constraint. A is greater than 10, then what? Digital write 9 comma high. Okay, I write digital write 9 comma high. Now what will be happening is that it will check for the value of a. What is the value inside the variable a? Okay, and if that variable is greater than 10, then the 9th pin will be turned high, or the LED will be glowing. If the value inside the a is less than 10, then it will not be happening. Okay, for you can also write an else statement. Else write 9 low. Okay, that means if this condition is satisfied, it will do this, or else it will do this. Okay, this is the condition statement. These are the basic. What?
This case it will be 9 low.
Yeah, it can be 9 low. For you can also set another pin like that. For example, if a greater than 10, digital write 9 comma high. Okay, else I want to turn on some other light bulb. Okay, for example, I can write else digital write 8 high. That is also a possibility. It need not be 9 low. Okay, if it is a is greater than 10, you can turn on the first LED. If a is less than 10, you can turn on the second LED. All these are possibilities. It need not be 9 low. Okay,
So where are we
so we have
specifying the ace value?
Where we will be specifying the ace value in outside this program. Before defining the program, you will be writing variable a. For example, int a is equal to 0. This is the initial value. Then I am writing, for example,
The C++, right?
yeah, analog read 8 comma a. Then the value from the 8 will be sent to a. Okay, then we have the value from 8 pin to a. Then we can use that a. Okay, these are our programming sites.
I have learned Python, that's easier.
Yeah, no, Python is easier, but C++ is the real program. So once you started doing the real coding, you came to know that Python is nothing but just outskirts of C++. So if you know C++, then you can learn any language. But if you know Python, it will be difficult to switch between languages. So better you have the best base in C++. Then switch on to Python, Java, anything, it's possible. But if you only know Python, it will be difficult. Yeah, then what? Serial communication. Yeah, serial communication. Serial communication is that, for example, our Arduino board is communicating between this PC and the board. Okay, this microcontroller and the PC. There is a communication between this microcontroller and PC. Okay, that is called serial communication. For that serial communication, we are connecting this wire. This wire is used for that serial communication. Okay, yeah, that's it. And this is the important commands. Okay, I'll explain one by one. This is part of programming, just to give an overview of how the program will look. Okay, first of all, we need to initiate the pin. We need to initiate the pin. For example, pin mode 13 output. Okay, what does this mean? I am initiating the 13th pin as an output pin. Okay, I am setting the mode of the pin, 13th pin. Mode of 13th pin is set as output. So I am saying the microcontroller that this pin, this particular pin of your microcontroller, this Arduino board will be set as an output. So you should not take any input from this particular pin. You will be giving output through this pin. So then you can connect your LED to this 13th pin, because it's set as an output. So once a condition is satisfied, it will be sending a particular 5 volt or 0 volt through this 13th pin, and if you connect an LED, it will be glowing. So I'm setting this 13th pin as output. So if I need to set, we have this 13 digital I/O pins. Okay, I means input and O means output. We have input output pins. So I am setting this 13th pin as output, and say I had connected a switch to 8th pin. I had connected a switch to 8th pin. So I need to set the 8th pin as input pin. What should I do? I will write pin mode 8, input. Okay, pin mode 8, input. That means I had set the 8th pin as input. Okay, now I can connect the switch to 8th pin, and the microcontroller will be waiting for the 8th pin to be turned on or off. Okay, if you press this switch, then microcontroller understand that okay, an input is coming from the 8th pin. It will analyze that input and it will process it and send an output to the 13th pin. This is the process. So inside the programming, you have to do like this: pin mode, pin, input or output. And that is the first thing. Second command is digital write and analog write. I already mentioned this thing, digital write 13, high. This will set the 13th pin to high. Okay, I had connected the LED to 13th pin and it will set the 13th pin to high. And we have delay. Delay is a function of, for example, if you are doing a blinking program, I'll write digital write 13 high, then delay for say 25,000. This 1,000 means 1 second. Okay, 1,000 means 1 second. 2,000 means 2 seconds, like that. Then 2,500 or 2,500 means 2.5 seconds. Okay, like that. So if you want a delay of 10 seconds, then you have to write 10,000. It's mentioned in milliseconds. Simple. So this is a function, delay function. So these are the basic commands which you use. There are lots and lots of commands you can go through while doing the programming. And yeah, that's all about the theory. Now we can do some practical. I'll show some practical. Okay, this is yeah, it's over, I know, but in order to clear all your doubts, it will take much more time, I know. So the blinking of the LED, connection diagram. So this is a simple connection diagram. You can connect the positive to the 9th pin and negative to the ground. Okay, so simply this is the connection diagram and this is a simple program. You can write the setup here. Inside the setup, I am setting up the pin mode 9 output. Okay, I am setting that 9th pin is for output and void loop. Inside the loop, you can write digital write 9 high. This means 9th pin is turned on. Turn on the LED. Then delay 1,000 means wait for 1 second. Digital write 9 low. Turn off the LED. Delay 1,000. Wait for 1 second. This is the structure of the program. How the program will be done in the Arduino IDE software. Okay. Inside the setup, we made the setup, and inside the loop, we will make the digital commands. So this was that, and I'll show some examples of the projects which you can do using Arduino. Okay, this is one of the project I have done. Let's see. This is the normal automatic hand sanitizer, which can be done using an Arduino board, a sensor. This is a ping sensor, which can be used, and this in this you are using a servo motor for controlling the up and down motion of this bottle. Okay, once you place your hand, the ultrasonic sensor will be sensing the position of the hand, and it will be activating this thing. Okay, and this was a workshop which I had taken in MES College of Engineering. And it's a robot which is being controlled using Bluetooth module and our smartphones. Okay, these are the simple projects which you can do using Arduino boards. And there are a lot of complicated projects, which, for example, I'll show some complicated projects, complicated robots, which you can do using Arduino boards. So these are some examples. These are from the workshops which I have taken. This is done. This is done in RIT Engineering College. This is MAS Engineering College. There are a few more. All these things are the projects which we can do using Arduino boards. Okay, and that's it. And I'll show some which you can do. You can build robots like this. You can see the robot.
Yes, sir.
Yeah,
Yes,
this is called Turtle Board Free Burger. It's a complicated robot which has a lot of functions, and yeah, it's a bit costly. It's cost around 50,000 rupees. But you can do much more good projects with robots like this. Yeah, so these are the possibilities of using Arduino microcontroller, and these are the projects which you can do, and you can do a lot of other projects also. And search on the internet for the projects which you can find. We can do using simple Arduino board, and you have also simple Arduino boards like this. I have shown the bigger one, and you have smaller ones like this. This is a smaller version of Arduino. This is Arduino Nano, which can be used for delicate projects like the size where there is a size constraint. If you don't have a size constraint, you can use this bigger one. Yeah, there are also a lot of sensors like this. This is a Bluetooth module, in which you can communicate your phone and the microcontroller like that. All these are the possibilities. So that's right. And if you have any doubts, you can either ask. If someone doesn't have much time, they can leave. And if someone has time and they have some doubts, they can stay. That's it. Thank you.
That analog
Thank you,
read
sir.
was for what?
Yeah, one second. I'll just come back to the. Here, what was the question? Analog read. Analog read is for reading the sensor values. Digital read, you will be reading the clicks, right? Once you press, you will get a press. And if you want to read a knob, if you are turning a knob and you need to get the value of the knob, then you will be using the analog read function.
So what is the difference between analog read and analog write?
Analog read is taking in the input, and analog write is giving out the output. That's very basic. If you had listened to the presentation very well, you might be knowing. Analog read, you are taking in the knob, and analog write, you are sending this value to some LED so that it will be glowing. Yeah.
If we are not giving this delay command, then what will happen?
If you are not giving the delay command, I didn't get you. If you are not giving the delay command in between,
What will happen? What will be the output? Yes, sir. Will the robot?
for example, if you
So he's asking what will happen.
yeah, if you write a program like this, if you write a program digital write 9 high and no delay, then it will be continuously glowing forever. That's it. And if you are not putting in delay in between, then Arduino will be having a clock delay, very, very minute clock delay, and you will not be able to notice the blinking between the high and low. If you are writing digital write 9 high, then directly writing digital write 9 low, then you will not be able to see the difference between high and low. Anything else?
So this presentation can be shared to us.
Yeah, I'll be sharing with the organizers. They'll be sharing with you.
Rest all clear.
Sorry? Yeah.
Thank
you, sir.
Thank you, sir.
Thank you, sir.
Okay, I think.
Bye.
Thank you,
Yeah,
sir.
I think we can wind up. Thank you.
Bye, sir. Thank you.
you, sir. Bye.
I would like to mention that right before we wind up the session, we wish to take a digital photograph. Also, we have provided a feedback form in the chat box. I request all the participants to fill up the form before you leave the session. I would like to thank all the teachers and the students for joining us today for this session. to be an interesting and insightful one. Our team is striving to provide you with an enriching learning experience, and we'll be conducting more such sessions in the coming weeks. And we hope you're looking forward to it as much as we are. So, now I request all the participants to turn on their cameras for a virtual photograph.
Thank you.
Thank you all.
Thank you, Miss.